So earlier in section 9.1, we saw this formula for the confidence interval for a population proportion, namely p hat plus or minus z alpha over 2 times the big square root of p hat times 1 minus p hat over n, which you should recognize from chapter 8 as the standard error of the sample proportion. When you want to make this interval or want to use this interval, you have to have a few conditions met. Namely, you need to have a point estimate, first of all, because all of it's built off of a p hat value. You need to have a simple random sample of size n. You need to have n times p hat times 1 minus p hat to be greater than or equal to 10. And you need your little sample size, which is n, to be less than 5% of your population size in order to ensure that the data or the distribution is independent, or the samples are independent, excuse me. All right, so all of those conditions need to be met in order to construct a confidence interval. And just on a side note, you do not actually have to memorize or even put this formula here on your note sheet. Let me show you why. In the back of your course pack, around, I would imagine, page 325 or so, there's some neon green pages that are called the Inferential Statistics Info Sheet. There's about 5 pages, 5 pieces of paper, so like 10 pages front and back. This entire packet, neon green packet, is just given to you when you go to take your test. So the testing center will actually just hand you this packet. Face-to-face students, online students, you all get the same thing. So the formula we're using right here is in section 9.1, and you can see it, it's right there. So you don't need to memorize it, it's right on the neon green sheets. Which now is as good a time as any to mention that what you want to do at this point is pull out these papers, all neon green papers from your course pack, staple them and put your name on them, because they will become your lifeline through the last chapters of the course. We will constantly refer back to this for formulas, for processes, etc., etc. So have this on you at all times. So pause me right now, take it out, staple it, put your name on it. You will constantly refer to this. You should not do any homework of any kind, any worksheets of any kind, any exams of any kind, without referring to the neon green packet from the back of the book. Okay, so we don't need to memorize the formula, but we do need these requirements, and those requirements could possibly be put into your note sheet for the exam, as well as remembering that the margin of error is half the width of the interval, always useful and helpful to know. Okay, so we learned how to find the z-score, which was inside that confidence interval. So now what we're going to do is we're going to actually find that confidence interval. First thing we're going to do is verify the requirements. So let me enter these in. Okay, so the first thing I have is I need a point estimate. If I don't have a point estimate, I can't do diddly squat. Well, luckily for me, I do have a point estimate. We already found it. It was 30 divided by 120, which was 0.25. So that's my p hat value. It will be the center of my interval. It is my point estimate. Sorry, I pressed the wrong button there. All right, the next thing I need is a simple random sample of size n. So do we have a simple random sample of size n? Well, of course we do, right? We assume, so yes, our scoop, which is our sample, was randomly selected. So I remind you of the bean box pictures. So all I did was take this scoop and just dip it into the beans and pull it out. That was it. I didn't really make anything special out of it. I didn't sit there and like pick out all the red ones and plop them into the scoop or anything. That would be a biased sample and that would be unfair. So I did not do that. And so therefore we have a random sample. All right. Then do we have n times p times 1 minus p greater than 10? Because we need to have that. Or n times p hat. Excuse me. We don't actually know what p is, so we'll have to use p hat. There, I cleaned this up a little bit. Okay, so I'm going to go find n times p hat times 1 minus p hat. N was 120. P hat we found above was 0.25. And then 1 minus 0.25. So I'm going to grab a calculator. This is going to take a second. There we have it. So I'm going to clear out the old. I'm going to type in 120. Oops. I don't know why that happened. There we go. 120 times 0.25 times parentheses 1 minus 0.25. You could all do it in parentheses as well, whatever. And you get 22.5. Well, 22.5 is indeed larger than or equal to 10. So, yay, we have a smiley face. So the answer is yes. Right? We do have normal, and it's because, here I'm just going to say B/C for because. So because n times p times 1 minus p turned out to be greater than 10, and everybody's happy smiley face. Right? So we proved it. You can't just say yes, you have to prove it. All right, then do we have independence? Well, yes, indeed we do. And I'm going to prove it. Here's why. Because n, which was only 120, is a lot less than 0.05 capital N. Capital N is how many beans there are in the box altogether. And you can see how little my scoop is in comparison to this big, 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 big box. That box is way bigger than 20 times this little scoop, right? And that's what 0.05 would be. It's 5 out of 100. In other words, N has to be 20 times, or capital N has to be 20 times little n. So this is a little bit weird because we don't actually know at capital N in this case, but we're going to kind of wave our hands at it like a magician and say, sure, we have this because our scoop, our little sample was so small, right? Scoop was so much smaller than the population size, i.e. the number of beans in the box. And that same argument, that kind of hand waving, like we're just going to say, yeah, of course we've got it. And you do that all the time with that particular one. So you tend to just kind of magically say you've got it. You're going to need that for your project as well. Just a little warning to you. Okay. So you kind of just say, well, of course my bag, of course my scoop is less than 5%. I mean, think of how many beans there are in that box. Think of how many beans there are in the world, things like that. All right, so now we have all the conditions met. Good job. So now we're going to construct the confidence interval, and that's going to require the formula, the substitution, and the results. And I'm not kidding around here. You actually have to show all 3 steps in order with all the parts labeled and everything. Okay, otherwise you do not get full credit. So let's start with the formula. So I know that the formula is that formula from the previous page. So it's p hat plus or minus z alpha over 2, and so on. All right, so there we have it. Step 1, formula. Step 2, substitution. Now, here's where all the hard work is and where all the points are. So you have to have your p hat, which is 0.25, plus or minus. Now, the z we'll figure out in a second. I'm just going to leave that blank for a minute. Then I'm going to have my square root, and then I have 0.25, 1 minus 0.25. That's p hat over, or times 1 minus p hat over 120, which was my n, right there. And then my final answer will be my result. But before I can do that, I have to fill in that blank for my z-score. If only I had spent a page finding z-scores. Ah, here they are. So if you look at it, we have a 95% confidence. 95% confidence is automatically 1.96 for your z-score. That's just how it is. You won't need to write it on your note sheet because I'm going to teach you a little trick for it in section 9.2, although you can write it on your note sheet if you so desire. So I'm going to put 1.96 right in here because that's my z-score. You have to write every single thing that is here, right? None of this can be skipped over. And you better make a note to yourself because you won't remember where that came from. So let me insert a column to the right real quick. Let me just type the z alpha over 2 equals 1.96 was found on the previous page. Right? Using inverse norm. Okay, so we already found it. That's where it comes from. Okay, so now that we know that, now we just need our results. Now, as much as I would love to say that every student can always put in this giant square root with no troubles, it gets a little problematic for typing that into a calculator. But luckily for you, you don't have to bother. Because when I gave you the inferential statistics sheet right here, the neon green sheet that you should have right in front of you right now, it says right here, you're doing a one sample proportion, there's the formula. And if you look right next to it, I say one prop z int, and I have it kind of highlighted in gray. What I'm telling you there is where it is on the calculator. So if I grab the calculator and I go to stat, now edit is where we've edited data before, calculate we've done one variable stats and stuff. We're going to move to tests. This is where we're going to be for the majority of chapters 9, 10, 11, and 12. And you want to scroll down and look for one prop z int, int. Don't look at the tests yet. Tests is chapter 10. You want to look for one prop z int, and there it is. It's letter A for me. So I'm going to grab that, and I'm going to tell it x, which we said was 30, n is 120, and my confidence level, my C level, is 0.95. And then this is different. You haven't had this before. It goes to calculate. It's been a while since you've had that, actually. You had it, I think, with finding one variable stats. So don't press any buttons. If you press a button like enter again, it takes you back to your last calculation, which isn't what you want. So go to stat, go to tests. It's actually closer to the bottom, so you're better off hitting the up arrow and kind of going from down below. It's letter A, and then you go down to calculate and press enter. And there it is, 0.17253 and 0.32747. Done. And we better say where we got it from. From one prop z int on calculator. There we go. Okay, now what does this mean for the beans in our box? We are 95% confident, so we are 95% confident that the true proportion of red beans is somewhere between these two numbers. There, somewhere between 17.253% and 13.747%. Done. Now suppose that some student in class, your neighbor in class, claims that more than a third of the beans in the box were red. So let's think about their claim. Their claim is more than a third. That the proportion, in other words, is greater than 0.3 repeating, right? Because a third would be 0.333333333 forevermore. So I'm looking for there it is. Okay. Now, does the interval back them up? Does it support or contradict their claim? Now, keep in mind, this is not a yes or no question. So when you're asked this on an exam, don't say yes. That's not a correct answer, and you get no credit at all. So you have to say support or contradict. And this is a contradict. And here's why. They're claiming that it's more than, right? But if you look, your entire interval is below, because the entire interval, which is 0.17253, 0.32747, is below 1/3, which is 0.3 repeating. Right, that's what a third is. Okay. Let's make a note real quick. Note, if the neighbor claimed that there were less than a third, then your interval would support. Right? So if they had claimed less than a third, then the interval would support that claim because the entire interval is below a third. So we need to be very, very, very careful when we're reading problems in this chapter in particular, but actually in all the remaining chapters, because just one word change from more to less changes your answer entirely, from a contradict to a support, and you have to explain accordingly. All right, we're all done with that problem, and I'll see you back here for the last one in section 9.1.